First thing I felt was pride, because I'd always wanted to do that, and I was really proud to have got in the seat and actually been able to fly it.
Forged in the crucible of Cold War tensions and multinational ambition, the Panadilla Tornado emerged not just as an aircraft, but as a testament to European aerospace collaboration, becoming a versatile and enduring multi-role combat powerhouse that would define NATO air power for decades.
I don't think anybody would ever say it was the most beautiful aeroplane they'd ever flown or the most agile, but it did its job. It did it well. So it was quite a complex beast. It was a lot of new stuff, not just for me as a young pilot, but for anybody going onto it. It had a lot of new technology. It wasn't just a question of light the engines and off you go. It would take a good 40 minutes to get it started up. If you go back to the 80s, it was height of the Cold War. The threats were pretty thick around the Iron Curtain, so the idea was to go in fast and low, ideally in bad weather or at night, and get underneath the defence system. So you practice day in, day out, flying low and fast. And we used to go to Canada and even up in northern Scotland where you could go and train in cloud at pretty much down to 200 feet, 500 knots, hands off. That was pretty scary stuff.
The Cold War tensions in Europe precipitated a critical shift in Britain's military aviation strategy. Following the TSR-2 cancellation in 1965, the UK would eventually find itself partnering with European allies to create what would become the Panadilla Tornado. But first, several technological and political hurdles needed to be overcome. The Soviet Union's deployment of advanced S-75 Divina, NATO designation SA-2 guideline, surface-to-air missiles, fundamentally altered NATO's tactical approach. This became painfully evident in 1959 when a Taiwanese RB-57, a United States reconnaissance version of the Canberra, was shot down by this system. Consequently, NATO strategists realized high-altitude bombing missions were no longer viable against sophisticated Soviet air defenses. Aviation experts determined that flying at low altitudes offered a solution, as the Earth's curvature created a radar horizon that rendered low-flying aircraft effectively invisible beyond certain ranges. This strategic shift prompted the British Air Ministry to develop General Operational Requirement 339 in November 1956, calling for an exceptionally ambitious aircraft. The period following the infamous 1957 Defense White Paper created confusion in military aircraft procurement. Initially, the document suggested that guided weapons would eliminate the need for new fighters or bombers. Nevertheless, merely 20 months later, the government reversed course and announced development of a new strike and reconnaissance aircraft. Despite being described as the most technically advanced aircraft in the world when it first flew on September 27, 1964, the TSR-2 project was controversially canceled by Harold Wilson's Labour government on April 6 after only 24 test flights, and having already cost approximately $500 million. This contentious decision stemmed from a confluence of issues. Persistent technical problems and development delays plagued the program. It faced significant political opposition, including skepticism from the governing Labour Party and key military figures who favored other aircraft. A cumbersome management structure also hampered progress. And ultimately, escalating costs reached a point described by the Secretary of State for Defense, Denny Healy, as an intolerable burden, a situation exacerbated by inconsistent government messaging regarding the TSR-2's primary role, whether nuclear or conventional strike. Following the TSR-2 cancellation, Britain initially announced plans to purchase a 110 General Dynamics F-111 aircraft from the United States. However, this order was subsequently canceled in January 1968 when the F-111 experienced its development problems and cost overruns. The Royal Air Force temporarily filled the capability gap with the McDonnell F-4 Phantom II for tactical strike roles and the Blackburn Buccaneer as a long-range strike aircraft. More importantly, This sequence of events ultimately reshaped the British aerospace industry. The cancellation of TSR-2, along with the P-1154 supersonic short takeoff and vertical landing fighter and HS-681 short takeoff and landing transport, forced British aircraft manufacturers to restructure and embrace international collaboration. British Aircraft Corporation participated in the Supacat consortium to develop the Jaguar and, more significantly, joined the Panavia consortium to create the Tornado. The Panavia Tornado emerged as the true successor to the TSR-2, offering similar capabilities through a multinational European partnership. Though smaller than the canceled TSR-2, the Tornado's variable sweep wing design provided the low-level penetration capabilities NATO required for Cold War operations. Panavia Tornado is born from European cooperation. In the aftermath of several failed aircraft programs, European nations recognized the need for multinational cooperation to compete with American aerospace dominance. This realization culminated in the formation of Panavia Aircraft GmbH in 1969, a watershed moment for European defense collaboration that would ultimately produce one of NATO's most successful combat aircraft. On July 17, 1968, representatives from Great Britain, Germany, Italy, Belgium, the Netherlands, and Canada signed the first Memorandum of Understanding, officially launching the MRCA 75 concept. Nevertheless, Belgium, Canada, and the Netherlands withdrew by October 1968 after the feasibility study began. The project was driven as much by political and economic considerations as by military requirements. As defense procurement costs escalated and public service sectors demanded more funding, collaborative development became increasingly attractive to European governments. The Anglo-German Agreement of early 1969 established the outline of the MRCA program and set general design parameters. Political bargaining heavily influenced work distribution. When the agreement was finalized, the United Kingdom and West Germany each received a 42.5% stake, with Italy taking the remaining 50%. This arrangement reflected the delicate balance of national interests rather than purely technical considerations. On March 26, 1969, the three remaining nations, Germany, Great Britain, and Italy, created Panavia Aircraft GmbH, headquartered in Munich. This landmark collaboration brought together the biggest names in European aerospace: British Aircraft Corporation, now BAE Systems, MBB, now Airbus Defence and Space, and Fiat Aviazione, now Leonardo. The consortium established a sophisticated work-sharing arrangement. British Aircraft Corporation would build the front fuselage and tail assembly, MBB the center fuselage, and Air Italia the wings. Additionally, a separate multinational company, Turbo Union, was formed in June 1970 to develop the RB99 engines, with ownership divided between Rolls-Royce 40%, NTU 40%, and Fiat 20%. This organizational structure laid the groundwork for future European aerospace collaboration, as noted by aerospace experts. The partnership established the Panavia Consortium in 1969 and laid the foundations for the birth of a true European aeronautical industry, which went on to establish the Eurofighter program. Full-scale development officially launched on July 20, 1970, followed by the first prototype flight at Manching, Germany on August 14, 1974. Throughout development, the program encountered challenges. 3 of the 15 prototypes were lost or seriously damaged during testing. The production contract was signed in 1976, with the first production aircraft taking flight on July 10, 1979. The Tornado finally entered service with the RAF's No-9 B Squadron. The MRCA program represented Europe's most ambitious multinational weapons development, with total costs exceeding $13 billion. The unit cost of each aircraft reached approximately $10.6 million, more than double the original 1970 estimate of $4.6 million. These financial constraints, along with the diverse operational requirements of 3 different air forces, dictated several key design decisions. The aircraft needed to perform multiple roles, including low-level penetration, reconnaissance, air superiority, and maritime strike, to effectively manage the demands of complex, low-level attack missions, both nuclear and conventional, particularly with the avionics technology available. The Tornado was fundamentally designed around a crew of 2, a pilot in the front seat and a dedicated weapons systems operator in the rear seat, responsible for navigation, targeting, and defensive systems. The design of 2-seat fighter aircraft really brings a lot of beautiful experiences and memorable memories to pilots.
The one thing that sticks with me though, which makes me really pleased that I was flying with someone else, was firstly, during an operational situation, it meant you were never alone. When the heat was on, there was always someone who had your back and vice versa. I think secondly, it developed a particular sense of camaraderie between colleagues and within the squadron. And lastly, it also taught you the real important value of teamwork, not just in flying the aircraft, but actually subsequently in everything that you do as well. So those things are probably gone. Other things are probably here to stay.
It's a difficult one for a backseater to answer that, but in truth, a lot of technology has changed since the advent of the Tornado, and there are lots of things that can be done by technology. But the advantage of having a second bloke in the cockpit is you've got a team, you've got a built-in team, whether you're airborne or on the ground. You've got 2 heads thinking about stuff, you've got 2 heads to look out of the aircraft, which is very important indeed. And when you land, you've got 2 people on the ground to go to the party.
I've flown both single seat and 2-seat, and I will be brutally honest with you, there's something quite special about flying single seat because you very much feel like it's just you and it's quite unique. But I am a firm believer that 2 brains are better than 1. You had to work hard at it. In order to be a better pair, you had to know each other. You had to almost instinctively know what each other was going to do. It wasn't a question and answer session. You literally anticipated what each of you was doing. And then when you got that synergy between the pair of you really humming, you were definitely more capable than a single seat. Obviously these days there are more sensors and systems, more artificial intelligence creeping in that will begin to make some of those decisions for the crews. But in those days we didn't have that. When you had a crew working well, it was quite something. And when you go to a reunion, you can very quickly see the pilot and the navigator who'd been crew together. They'll be in the corner drinking a beer together.
As a result, engineers created a twin-engine, variable sweep wing design that could adapt to different flight phases. This versatility allowed the Tornado to adjust its wing configuration for optimal performance in varied mission profiles, making it particularly effective for low-altitude penetration of enemy airspace, a crucial capability during the Cold War. The final design incorporated sophisticated systems to address stability issues discovered during flight testing. Over time, the aircraft received more advanced stability augmentation systems and autopilots, evolving into 3 main variants: the interdiction, strike, electronic combat, reconnaissance, and air defense variant. Despite being started 1 year before the F-15, the Tornado entered service 6 years later than its American counterpart, an indication of the complexities involved in multinational development. Nevertheless, the program ultimately produced more than 990 aircraft, establishing itself as Europe's largest military aircraft cooperation effort. What made the Panavia Tornado a multi-role powerhouse? Designed from the ground up as a combat aircraft for multiple mission profiles, the Panavia Tornado introduced innovative technologies that established it as a versatile war machine. The aircraft's exceptional flexibility allowed it to operate effectively across various roles, from low-level penetration strikes to air defense and reconnaissance. The Tornado's exceptional versatility stemmed primarily from its variable geometry wing design, which enabled optimal performance across different flight profiles. This swing wing configuration allowed the aircraft to adjust its wing sweep between 25 degrees and 67 degrees, significantly enhancing its aerodynamic efficiency across various speed ranges. With wings swept back, drag decreased substantially, facilitating high-speed, low-level flight, crucial for penetrating enemy defenses. Powered by twin-turbo Union RB199 turbofan engines, generating 17,500 pounds of thrust each, the Tornado could reach an impressive top speed of Mach 2.2 at altitude. Despite its size, the aircraft was remarkably compact and achieved the highest lift coefficient of any supersonic aircraft of its era. This engineering achievement made it the fastest combat aircraft of its time at sea level in clean configuration. The Tornado's payload capacity was equally impressive, carrying up to 19,841 pounds of ordnance distributed across 7 hardpoints, 3 under the fuselage and 4 under the wings. This substantial capacity, combined with its advanced avionics, established the Tornado as an extraordinarily versatile weapons platform. Unlike many contemporary aircraft, the Tornado featured thrust reversers, a rarity among fast jets. This technology allowed the aircraft to stop within 2,500 feet after landing, enabling operations from damaged or shorter runways in combat scenarios. Consequently, the Tornado could deploy from a wider range of airfields than many of its contemporaries. Originally conceived as a long-range, low-level interdictor with primarily nuclear armament, the Tornado was specifically designed to counter Warsaw Pact forces in a potential World War II scenario. Its capacity to deliver both B-61 and WE-177 tactical nuclear weapons positioned it as a vital component of NATO's nuclear deterrent strategy. The gravity of this role was deeply felt by those who served.
Some of the highlights, probably my first tour on a squadron when I was combat ready and being put into the quick readiness alert, which for the ground attack aircraft was the nuclear role. I remember going up and signing for my aeroplane with 2 nuclear weapons strapped under it for the first time, and then going into my hardened shell tour on 15-minute readiness to be launched to go drop them. That was a pretty momentous day, I remember.
Nevertheless, the Tornado proved equally effective in conventional warfare roles. Its advanced sensor and defensive aids suite enabled deep penetration missions in all weather conditions, day or night. This capability was enhanced by its combined navigation attack Doppler radar system that simultaneously scanned for targets while conducting fully automated terrain following for safe low-level flight. Even in cloud, at night at altitudes as low as 250 feet, the aircraft's electronic warfare capabilities further expanded its versatility. The Tornado was the first Royal Air Force aircraft fully designed for the complex age of electronic warfare, with systems to jam or deceive enemy defenses. This electronic sophistication allowed it to adapt to the evolving battlefield throughout its service life.
Compared to other aircraft I've flown before that once you get airborne and you get the aircraft cleaned up and you're flying at low level, it's really quiet and almost a divorce from the kind of environment around you. So something kind of quite special, and at the time it felt really modern as well and kind of right up there with all the technology that was around.
The airplanes were straight from the factory floor, so all nice and shiny, almost like taking your brand new car out of the dealership. So lots of fun.
Over time, the Tornado demonstrated remarkable adaptability across multiple combat scenarios. From using JP-23-3 runway denial weapons during early conflicts to later deploying precision-guided munitions like Paveway 4, Storm Shadow cruise missiles, and Brimstone anti-armor missiles, the aircraft continually evolved its weapons capabilities throughout its operational life. Through this combination of variable geometry, sophisticated avionics, substantial payload capacity, and all-weather capability, the Tornado established itself as one of the most adaptable combat aircraft in aviation history, effectively fulfilling multiple roles that would typically require several specialized aircraft types. Tornado variants. Panavia manufactured the Tornado in 3 distinct variants, each tailored for specific operational requirements, while sharing the same base airframe. These specialized versions allowed air forces to deploy the versatile combat aircraft across a spectrum of missions without sacrificing performance in their primary roles. Tornado IDS interdictor strike capabilities. The interdictor strike variant served as the core version of the Tornado aircraft, adopted by all partner nations with minor variations. As the first European military aircraft designed with fly-by-wire flight controls, it specialized primarily in ground attack missions. The IDS featured comprehensive navigation equipment, including terrain-following radar, Doppler radar, and a 3-axis digital inertial navigation system for precise targeting in all weather conditions. Its fixed armament comprised two 27mm IWK aim-user cannons on each side of the lower fuselage with 80 rounds per gun. The aircraft utilized 7 hardpoints, 1 centerline pylon, 2 fuselage, shoulder pylons, and 2 swiveling pylons under each wing. This configuration allowed the IDS to carry various weapons, including conventional bombs, laser-guided munitions, and anti-radar missiles. Each partner nation developed specific adaptations. The Royal Air Force designated their attack version as the GRMK-1, incorporating an extra fuel tank in the tail fin. They subsequently created the GR-1A for photoelectronic reconnaissance and GR-1B for anti-shipping missions. The German Navy and Italian Air Force Tornadoes received modifications to operate the Cormoran anti-ship missile. Tornado ECR, Electronic Combat and Reconnaissance. The Electronic Combat Reconnaissance variant represented a specialized development focusing on suppression of enemy air defenses. Operated exclusively by Germany and Italy, the ECR retained the IDS's proven capabilities while incorporating sophisticated electronic warfare equipment. The most significant modification involved removing the Mach cannons to house the emitter location system in the gun bays and wing roots. This system could detect, locate, and classify enemy emitters, including air defense radars and communication stations. The aircraft also featured a forward-looking infrared system and additional sensors, with German ECRs having larger black panels on the wing gloves than the IDS version. Primarily, the ECR carried the AGM-88 high-speed anti-radiation missile, a potent weapon with considerable standoff range that could identify and home onto various radar types. The missile could be fired using position information from the emitter location system without acquiring the target until after launch, creating a lethal defense suppression capability. Germany received 35 new-build ECRs, whereas Italy converted 16 existing IDS platforms to ECR configuration. Tornado AD Air Defense variant for long-range interception. The air defense variant fulfilled a uniquely British requirement for defending large stretches of airspace, particularly north of the British Isles. Developed specifically as a long-range interceptor rather than an air superiority fighter, the ADV underwent significant modifications to its airframe and systems. Most notably, the ADV featured a 1.36 meters longer fuselage to accommodate the GEC Marconi Foxhunter radar in a more streamlined nose section. The underside was modified to permit installation of 4 Skyflash radar-guided missiles, requiring a 53-centimeter fuselage extension behind the nose wheel bay. To enhance range and loiter capability, engineers removed the left-hand cannon and installed an additional fuel tank, providing approximately 900 liters of extra fuel. The radar system, designated AI-24 Foxhunter, fundamentally differentiated the ADV from other variants. It could track up to 20 targets simultaneously at ranges reaching 60 kilometers, enabling beyond visual range engagements. The ADV entered service in 2 subversions, the F2-18 aircraft with an interim radar and the definitive F3, which later received upgrades to carry AIM-20 AMRAAM air-to-air missiles. For pilots transitioning from older aircraft, the Tornado ADV offered a significantly improved flying experience.
A lot easier to fly. It was a lot cleaner, slightly larger cockpit, slightly more roomy, more comfortable, everything a little bit more modern, as you'd expect. And indeed, about 6 months after starting on the F3, in fact, just after 11 Squadron went out to Cyprus, having declared, 228 OCU had left a Phantom behind in the hangar. So it was only 6 months since I last flew it, but one of us who were ex-Phantoms went into the hangar to have a look, see, and when I went up the steps and looked inside, I thought, my goodness, the black hole of Calcutta, did I actually work in that? So in terms of an environment, it was a whole lot better.
Yeah.
Easier to fly, yet there was a little bit more, there was more performance. Don't say there's more thrust, there's more performance for it. But it obviously had a major weak point at that stage, and most of that was in the back cockpit. And I don't mean the personnel, I mean the equipment available to the man in the back. And that's where it got most of its bad publicity in the late 80s, early 90s.
These initial difficulties with the Foxhunter radar and associated systems were eventually addressed through subsequent upgrades, allowing the ADV to mature into a capable long-range interceptor. Where did the Tornado prove its combat effectiveness? The battle-tested Panavia Tornado established its combat credentials through numerous conflicts spanning 3 decades, proving the aircraft's effectiveness across diverse operational environments. The Gulf War marked the Tornado's baptism of fire in 1991, with the Royal Air Force deploying 60 aircraft to bases in Bahrain and Saudi Arabia. These aircraft logged more than 1,500 sorties throughout the conflict, though 6 Tornadoes were lost and 5 crew members killed. In the 2011 Libya campaign, RAF Tornadoes launched several Storm Shadow missiles against air defense targets, completing remarkable 2,600 nautical miles sorties from Royal Air Force Marham. This represented the longest-range offensive tasks conducted by the Royal Air Force since the Falklands War nearly 30 years earlier. German Tornadoes participated actively in Operation Allied Force during the Kosovo War in 1999, marking Germany's first offensive air mission since World War II. The ECR variant proved particularly valuable, escorting Allied aircraft while carrying AGM-88 high-speed anti-radiation missiles to counter enemy radar systems. Throughout this conflict, German Tornadoes flew 2,108 hours across 446 sorties, firing 236 high-speed anti-radiation missiles at hostile targets.
My first operational sortie into Kosovo and being shot at by Serbian air defenders. Clearly they missed. But yeah, there are many memories.
Yes, in terms of particularly memorable sorties, we've got a few actually, but probably the most memorable one is the 25th of May 1999, when we flew a very interesting combat mission in the war in Kosovo. And we were leading the formation, and we had a particularly exciting time, which I think my learned colleague can now take over from.
Yeah, it was quite a night in Kosovo, 25th of May, to the extent that we celebrate it every year. We've been there a couple of times before, and in general terms, there was some action, but we'd been left pretty much alone. And that night was particularly interesting because as we coasted over the water and got into the operational area, our RHWRs lit up. And it was very difficult to differentiate what was spoof, what was real. There's a lot of jamming. It was a very active area of operations. All 6 of our aircraft came under attack from surface-to-air missiles, which we all saw visually. And we ended up in different places. Some of our colleagues managed to successfully evade the missiles and drop their ordnance on target, which was incredible. Some ended up in countries they shouldn't have been in for a short period of time during that night, just to get out of the line of fire. And we got back into Bruggen with the help of our air-to-air refueling colleagues a good 4 or 5 hours after that. So quite a night. I think what that night brings home to me is a couple of things. Firstly, how your training as a crew kicks in automatically when the pressure is on, but also how well the aircraft performed that night. You know, we were performing that aircraft to the maximum limit that night on several occasions. Everybody came home, and I think we're really grateful to ourselves for that, but also to the airframe that we were in that night.
I'd like to add something to that. That it's worth noting we had 2 targets to attack that night, and despite the intensity of the surface-to-air fire, we hit both targets. And Jockey and I were at the front. Between us, we were working very hard, and you can hear that on the tapes. You can hear us breathing very hard. A lot of G going on, a lot of very, very violent manoeuvres as we manoeuvre from about 25,000 feet down to a much lower level and then back up again. But in the course of all of that, I, as the backseater in charge of getting rid of the fuel tanks, was on the verge of jettisoning them, and I shouted that I was going to do that in order to free up the weight and therefore allow him more agility. And Jockey shouted, "Don't. There's a little town down there. I know that's mad, but you know what I mean." So we hung on to them for a little bit longer, putting ourselves in jeopardy, really, just to make sure that we didn't inflict any collateral damage on that village below us.
This single engagement starkly illustrates the dangers faced, the reliance on training, the capabilities of the Tornado under extreme duress, and the critical importance of crew coordination and ethical considerations, even in the heat of battle. Initially, Royal Air Force Tornadoes executed dangerous low-level attacks against Iraqi airfields using JP-23 runway denial weapons. These missions required precise delivery parameters, approximately 160 feet altitude with wings, level, and no banking. During the first 4 nights of Desert Storm, Tornado crews conducted 53 JP-233 raids against Iraqi airfields, expending 106 weapon systems. The attacks typically involved 4-ship formations targeting critical runways. On January 19, 1991, 8 Tornadoes from No. 27 Squadron attacked Talil Airfield, despite encountering intense anti-aircraft fire. After 5 days of operations and 4 aircraft losses, tactics shifted to medium-level operations at around 20,000 feet, where only larger surface-to-air missiles pose serious threats. Operations in Bosnia during 1993-1996, under Operation Deny Flight, reinforced the limitations of traditional tactics, as one Royal Air Force pilot noted. "We were regularly fired upon while patrolling the UN-mandated no-fly zone. Effectively, these experiences highlighted the need for precision munitions rather than traditional bombing approaches." In Afghanistan, 7 Royal Air Force squadrons operated GR-4s from Kandahar between 2009 and 2014, accumulating 33,500 flight hours. Here, the Tornado Force largely abandoned low-level tactics in favor of medium-altitude operations, capitalizing on the increased accuracy of modern weaponry. This operational shift reflected a fundamental lesson. Sophisticated precision-guided munitions provided better effectiveness while reducing aircraft vulnerability compared to traditional low-level penetration tactics. Flight Lieutenant John Overton, a navigator in the Tornado GR-4, provided a first-hand account of their demanding roles during this period.
Well, we do 2 roles out here. We do close air support, but we also have the reconnaissance pod for close air support in the back seat. I control the sensor pod that looks down onto the ground from sort of 3 or 4 miles up, and I prepare the weapon packages. Whilst the pilot's flying around, he deploys the weapons that are pre-set in the back seat by myself.
Detailing their arsenal, he explained.
There's 3 main weapons that we have. Like most platforms, we've got a gun, so a point and shoot capability. Direct fire is seen as a much better lower CDE weapon. We've also got a forward-firing missile, a real low CDE for small targets, moving targets. Great weapon out here to avoid civcas. And then also, if we really need to take down buildings, anything like that, our largest weapon is our 500-pound bomb, which can be GPS guided or laser guided, either way.
The nature of their missions was predominantly focused on direct support to ground forces.
Our main role is the close air support. Obviously, loads of guys out on the ground. So we do mainly routine tasking. Probably about 80 to 90% is just out overwatching guys out on the ground doing patrols. But the highest priority tasking we have is support to troops in contact. And then lower down from that is just other high priority tasking called prize in the AO. Well, I mean, obviously ISAF, it all needs to be, regardless of nationality, we're all here to do the same job, so we need to be able to work with any of the nationalities despite any language barriers. Obviously working with Americans or our own British forces, it's a lot easier to understand what's going on, but we frequently work very far in the northwest with the Italians and further over to the west as well. We work with all sorts of guys on the ground, regardless of nationality. So every platform needs to be able to support every nationality because it's one team, one fight. The only guys we speak to on the ground, unless it's an emergency close air support, we're always speaking to the JTAC. So predominantly the US Marine Corps, we're quite frequently with them on the ground.
The demanding nature of these operations underscored the value of the Tornado's two-crew design.
It's tiring, it's hard work, but also when it gets going and it gets busy, you can share your workload between the two cockpits, which is a great advantage of this jet. But my job personally, when I came out here, pretty much joined on basis of 9/11. So it was nice to get out here and to get involved and help the guys on the ground, especially with the reconnaissance that we do. We soak up so much of the imagery on the ground, pick out a lot of IEDs that hopefully it's saving a lot of people getting any damage to themselves.
This detailed perspective showcases the critical role the Tornado GR4 and its crews played in supporting ground operations and saving lives through precision strike and vital reconnaissance. Throughout 4 decades of operational service, the Panavia Tornado underwent extensive modernization programs that transformed an already capable platform into an increasingly sophisticated combat aircraft. These upgrades allowed the aircraft to adapt to evolving threats and maintain battlefield relevance long beyond its intended service life. The upgrade from GR1 to GR4 standard began in 1996, following lessons learned during the 1991 Gulf War, and continued until 2003, with 14-2 aircraft eventually receiving this modification. At the core of this upgrade was the implementation of a 5053 data bus coupled with a 11760 weapons data bus, enabling integration of advanced systems and weapons. The GR4 featured forward-looking infrared capability and night vision goggle compatibility, creating an all-weather, day-night operational platform.
It was an excellent upgrade of the nav system, but also an inclusion of a forward-looking infrared suite as well, which allowed us to fly at night. If you remember that, we'd previously had night vision goggles, but we'd rarely used them really, but we now had a completely compatible cockpit.
But I remember the first time when we flew from RAF Bruggen across to the UK and we dropped into low level over the Scottish border. It was a beautiful night vision goggles, manually flying the aircraft at 250 feet. That was some rush. It really was incredible. And to me, that really brought the aircraft to life, because not only could we do that, but we could then go from visual flying to instrument flying, all at low level, all below the radar, which really kind of brought the capabilities of the aircraft right to the fore. It was absolutely incredible experience.
German Tornadoes received parallel upgrades through the avionics system software Tornado ADA program. AS-3 incorporated a multifunctional information distribution system with Link 16 capability, digital video and voice recorders, and new radio equipment, as STA 3.1 subsequently replaced monochrome displays with color alternatives. In 2010, the first production STA-2 upgraded Tornado was delivered to the Luftwaffe. The weapon systems underwent substantial enhancement throughout the Tornado's service life. POBWay 4, a dual-mode GPS INS and laser-guided precision bomb, was integrated with Tornado GR4 under an urgent operational requirement, costing approximately 4 million British pounds. This is a 498-pound weapon that significantly improved the aircraft's precision strike capability with its all-weather 24-hour operation profile. Likewise, both Storm Shadow cruise missiles and Brimstone anti-armor missiles became integral to the Tornado's arsenal. The Storm Shadow integration allowed for standoff precision attacks, while Brimstone provided the ability to engage moving and maneuvering targets on land and sea. These weapons were later transferred to the Eurofighter Typhoon under Project Centurion, In later service years, 3D printing technology supported the Tornado fleet maintenance. Scale model parts produced intricate cockpit components for GR-4 aircraft, including the traffic alert and collision avoidance system. This technology allowed the reproduction of detailed parts no longer in production. Additionally, Airbus Defence and Space conducted airframe life extension programs on 85 Luftwaffe Tornadoes, increasing their service life from 6,000 to 8,000 flight hours. This complex process involved reproducing approximately 400 structural parts that were never intended for replacement, effectively extending the aircraft's service until why the Tornado's legacy still matters today. Beyond its operational achievements, the Panavia Tornado's influence extends far beyond its active service years. As European air forces transition to newer platforms, the aircraft's legacy continues to shape military aviation in multiple dimensions. The Eurofighter Typhoon's development drew directly from lessons learned during the Tornado program. Many of the companies involved in the Tornado project later formed the Eurofighter consortium. The experience gained in international collaboration, systems integration, and combat aircraft production was directly transferred to the Typhoon program. Both aircraft share the same basic engine core design philosophy, with the Typhoon's EJ200 engines representing an evolution of the Tornado's RB99 technology. Operationally, the Typhoon incorporated several capabilities proven on the Tornado, including advanced terrain following systems and multi-role flexibility. The Typhoon's weapons integration process benefited accordingly from the Tornado weapons integration experience. Under Project Centurion, the Royal Air Force successfully transferred Brimstone, Storm Shadow, and Pavway 4 weapons from Tornado to Typhoon, ensuring operational continuity between platforms. The Tornado program established a blueprint for international defense collaboration that remains relevant today. Its trinational structure demonstrated how countries could pool resources to develop sophisticated military technology while sharing costs. This model influenced subsequent European defense initiatives, establishing a pattern for balancing national industrial interests with collective security needs. Moreover, the program created lasting industrial partnerships across borders. The work-sharing arrangements, pioneered during Tornado development, became standard practice in later collaborative efforts. The program conclusively demonstrated that effective defense collaboration required political commitment, technical standardization, and industrial cooperation. The Tornado's design philosophy continues to influence modern combat aircraft development. Its variable geometry wing configuration represented a practical solution for reconciling contradictory performance requirements. Although newer designs have moved away from variable geometry wings, the underlying principle of versatile mission capability remains central to contemporary aircraft development. Furthermore, the Tornado's evolutionary development path demonstrated how a well-designed airframe could adapt to changing operational requirements over decades. This approach to platform longevity through incremental upgrades has become standard practice across modern military aviation programs. The Panavia Tornado's story is more than just one of advanced engineering and multinational cooperation. It is a narrative woven with the dedication, bravery, and pride of the countless individuals who designed, built, maintained, and flew this remarkable aircraft. As its operational life in many air forces draws to a close, the sentiments of those who knew it best encapsulate its enduring legacy. Ultimately, the Panavia Tornado will be remembered not only for its innovative design and combat effectiveness, but also for the indelible mark it left on European air power and the generations of aircrew who affectionately called it the Tonka. Its legacy continues to inform future aerospace endeavors and serves as a testament to what can be achieved through international partnership and unwavering dedication.